So in this video, we're going to solve the linear equation for the given variable. So our first example here is 4x minus 3 divided by 2 plus 3 over 8 equals 7x plus 3 over 4. All right, now, guys, denominator here is different for each of these parts. I don't like fractions. You don't like fractions. Let's get rid of fractions. To get rid of the fractions, what we do is we multiply by the least common denominator. The least common denominator between these three numbers is 8. Okay, if I multiply 2 times 4, I get 8. If I multiply 4 and then multiply that by 2, I get 8. And then 8 times 1, that's 8. So if I multiply everything by 8, okay, we're going to get rid of our fractions. So let's do that. I'm going to multiply through. So I have 8 multiplied here, and that equals, and then I distribute here, I have 8 multiplied by 3/8, and I distribute here, and I have plus 8 multiplied by 4x minus 3 over 2. And so now what am I going to do? I'm going to simplify. Now this 8 here, I'm multiplying by 8 for each piece right here. 8, you can write 8 over 1, 8 over 1, 8 over 1. That's still 8, right? And so what do I see here? This 8 cancels with that 2 there. What is 8 divided by 2? 8 divided by 2 is 4, right? So this becomes 4. So what do I have? I have in parentheses multiplied by 4. What's in parentheses here? Is that 4x minus 3, right? And then the next piece, well, what happens here? This 8 cancels with that 8, and so what am I left? I'm just left with this 3 here, okay? And then that's equal to, now 8 and 4 cancel, and so what do I have? In my parentheses, I have 7x plus 3 multiplied by the 2, okay? So now I'm going to distribute, okay? Distribute the 4. I get 4 times 4 is 16x. 4 times negative 3 is negative 12 plus 3, okay? This is equal to, and then distribute the 2. I get 14x, and then distribute the 2 again. I get plus 6. All right. Now, I have x's on both sides of my equation. First thing I like to do, though, before I do anything else is collect like terms. So I'm going to collect over here and collect over here. It looks like the right side's good, so I just need to collect this here and here. So negative 12 and 3 makes negative 9. So that's 16x minus 9 equals 14x plus 6, right? Okay, now what am I going to do? Well, I need to get my x's on one side of the equation, on the equal side, and the numbers, the constants on the other side. All right, so you've got a couple options here. You can either move the 16x or you can move the 14x. To me, it does not matter. Sometimes students, they like to avoid negative numbers, so they always move the smaller one. If that's what you want to do, great, move the smaller one. But either way is going to get you the same answer. So we ask ourselves, what is the opposite of adding 14x? It's subtracting 14x. But since this is a balancing equation, if I do something to one side, what do I have to do? I have to do the exact same thing to the other side, okay? And so when I do that, what do I get? I get 2x minus 9 equals what? 6, okay? So now we're working our way. We're trying to get x by itself, okay? So I think about what is the opposite operation of subtraction? It's addition. So I'm going to add 9 to eliminate it on both sides. When I add 9 to both sides, what do I get? I get 2x is equal to, well, what is that? 9 and 6 make 15. All right, so now I think, okay, I'm trying to get x by itself. X by itself. What is the opposite of multiplication? That is division. So what I'm going to do is I'm going to divide both sides by 2. And when I divide both sides by 2, the 2's cancel. And so what do I get? I get x equals 15 over 2. Now, if they don't specify, you can leave it in this fraction form right here. That's perfectly fine. And in fact, most times I think they want it in fraction form. But if you had to do decimal, you just type it in your calculator. 15 divided by 2, and you get 7.5, right? So what if you got like the 7.5, you got 7.5 as your answer, and it's like, well, I want a fraction form. What do? You hit the math, and then enter for frac button, and hit enter, and you get the 15 over 2, okay? So that's a way to convert between decimal and fraction using your TI-84. All right, is this an example? So this equation, is it an identity? Is it a contradiction? Or is it a conditional? Right? I have x equal to a particular number, 15 divided by 2. Is it an identity? No, it is not an identity. Why is it not an identity? Because identity has to be for all x, right? Is it a contradiction? No, it's not a contradiction because that has to be for no x. Well, there is exactly one x that works, right? So that works. So that can't be a contradiction. So what does it have to be? It's a conditional. Why is it conditional? Because it works for 15 over 2, but it don't work for all other x, okay? So it don't work, right? So conditional, it's conditioned on being a certain value. So it works for x equal to 7.5 or 15 over 2, but it does not work for any other x value that you choose. If you choose x equals 0, it fails. X equal 15, it fails, right? If I plug in a 0 into this equation, right, or this one up here, it doesn't matter. It's not going to produce a true answer, okay? So if I plug a 0 in, that's going to get me -9 equals 6. That is a false statement. -9 does not equal 6. Okay, so the only one that x value that produces a true statement is 15 over 2. Okay, so that is the idea behind a conditional. There's only certain values that actually works. And like 95% of the problems we do are conditional. So most of the problems we do are conditional. Do you run into identities or contradictions? Sure, you do. It happens. Okay? It definitely happens. All right, it graphically, and we'll talk about this later in the class, but I can introduce it now. A conditional, graphically, is this scenario. When you're talking about linear equations, it'd be this scenario where there's one intersection. A contradiction would be the scenario where we're talking about like two parallel lines. The intersection is where the solution is, right? Well, they never cross, so there's no x value that works. And an identity would be the scenario where it's like you got a line, but then you got another line right on top of that line. And now every value on that line is a solution. So all x's work. Okay, so those are the three scenarios graphically. And like I said, we're going to talk about this later in the course. I just wanted to kind of show you that. So you don't need to know that for right now. Okay? All right, next problem. We've got 0.24x plus 0.58 times x minus 6 equals 0.82x minus 3.67. Now, those decimals are annoying, okay? Super annoying. So I want to get rid of the annoying part. So I'm going to multiply everything by, well, it looks like we got 2 decimals, so we need to move it over at least 2 places. So I'm going to multiply by 100. And what that's going to do, if I multiply by 100, I get 24x plus 58 times x minus 6 plus, or equal to 82x and then minus 367. Now you might be asking yourself, why didn't I multiply by this piece right here? Well, you have to be careful. What's separating these two pieces? It's a multiplication, not an addition, okay? So if you think about it, if I'm going to multiply 2 times 3 times 4, I multiply 2 times 3, right? And I get 6. And then I multiply that by 4, and I get 24. I don't say 2 times 3 and then 2 times 4, right? Because that would give me 6 times 8, which is 48. That's too big, right? That doesn't work. So you don't multiply the 100 by each of those pieces. You only multiply by that separation of the pluses and the minuses, okay? So just, common mistake I see. Trying to help you out since I'm not there in person. Try to give you all the warning signs of what people do, how they mess it up. So I have 24x, and then plus, and I have 58x, and then, 58 times negative 6. What in the world? 58 times 6. So negative 348 equals 82x minus 367. Okay, combine like terms. What do I get? I'm going to get 24 plus 58 is 82x minus 348 equals 82x minus 370 or 67. All right, subtract 82x from both sides. Uh-oh. Oh man, my x's went away. So I have negative 348 equals negative 367. When is that true? That's never true. So what does that tell me? That's a contradiction. That is a contradiction. All right, so it's not the same number, it's a contradiction. All right, so that is definitely a contradiction right there. Okay, let's try another example. Try another one. So let's do 2x plus 7 equals 9 times parentheses x minus 2 close parentheses minus 7x plus 25. Okay. So it doesn't look like a whole lot to do over here, but we can simplify this. Multiply, distribute. 9 times 1x gets me 9x. 9 times negative 2, negative 18. I have minus 7x and plus 25. So I'm going to combine the like terms. Negative 7x and a 9x make a 2x. And then negative 18 and plus 25 makes a positive 7. So this is equal to 2x plus 7. Uh-oh, I kind of see where this is going. Minus 2x gets me no x's. I have 7 equals 7. Is 7 equal to 7? Always. So is this a contradiction? No, this is the opposite of a contradiction. This is an identity. This is always true. Okay, it's an identity. Okay, so it's always true. No matter what x you plug in, it will always satisfy the equation. Okay. All right. Hopefully we've given you some steps and tricks that help you solve for x. Okay. The biggest thing about solving for equations in one variable, if you do something to one side of the equation, you got to do the same thing to the other side of the equation. Okay. So, and you always think, what is the opposite of the operation? So the opposite of addition is subtraction. The opposite of multiplication is division. All right, so it's the inverse. When I say opposite, I'm talking about the inverse operation. Okay, so just always think if you're going to do something on one side, make sure to do the same thing to the other side. Okay, and as long as you follow those rules, all right, then even if you take the long way to get to the answer, you can still get there.